Hello, today we are continuing to graph linear equations, but we're going to do so with a restricted domain. As a start, we're going to review how to just graph a function using a table. So this one is already solved for y, but if it's not solved for y, you need to solve for y first, or get it in function form. Then we're going to make our table. Our xy table with space in the middle to solve the problem. X, y. And now this one, our equation goes in the middle, 1/4 x minus 2. We can't just pick any number for x because of the fraction. We're going to end up with weird decimals. So if we instead pick multiples of 4, we won't have weird decimals. So 4 and then another 4 would be 8 and so on. But I'm going to do a couple positive and a couple negative. So let's plug this in. We have first 1/4 times x, and x is first a negative 8. And then we're going to subtract 2. So 1/4 times negative 8, well, let's just plug that in my calculator. In parentheses, because it's a fraction, 1 divided by 4. And then we have times a negative 8. If you want to push enter, you can, but we need to again subtract 2. So we should have a negative 4. If you wanted to type that in all at once, you could put 1 divided by 4 times negative 8 and then minus 2. It gives you that all at once. So let's try the next one. We have 1/4 times x, which is a negative 4. And then we're going to subtract 2. So 1/4 times negative 4 and then subtract 2 is a negative 3. So we have negative 4, negative 3. You can probably predict what's going to come next. We have 1/4 times 0 and then minus 2. Anything times 0 is just 0. So we have 0 minus 2 is negative 2. Negative 4, negative 3, negative 2. Next would be negative 1 and then 0 if we're following the pattern. And if you figure out the pattern, awesome. If you want to keep plugging in 1/4 times 4 minus 2, 1/4 times 8 minus 2, you can, but you'll get the same answer. So let's plot these x, y. X is negative 8 and y is negative 4. I'm going to write out all of my points first. Negative 4, negative 3, 0, negative 2, 4, negative 1, and 8, 0. Here's x, here's y, and then plot our points. So x is negative 8, so not to the right, but to the left because it's negative like our number line. Negative 1, 2, 3, 4, 5, 6, 7, 8. And then negative 4, it's not up, it's down. Negative 1, 2, 3, 4. There's the first one. Then negative 4 on my x-axis. Negative 1, negative 2, negative 3, negative 4. And then down 3. 1, 2, 3, because it's negative. Positive numbers would be to the right or up. And then we have 0, negative 2. So we're not going left and right, we're just going down 2 right there. I'm going to make this one a different color so we can see it. And then we have 4, 1. X is 4 to the right. Up 1. Oh, not up 1, down 1. And you guys see that didn't even make sense. See how it didn't form a nice straight line? I made a mistake. I have to go down 1. And then 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. And then we're not going up and down. It's 0. So here are our points. Put a line through them to show that they form a nice straight line. If they don't, you made a mistake. Like earlier, I put the point here instead, and that didn't form a straight line. So I knew I did something wrong. Next, we're going to do the same thing, but graph with a restricted domain. So if I told you you are restricted from doing your homework, that would mean that you don't have to do your homework. We're cut off. We have to stop. If I told you you're restricted from going into certain parts of the library, that means that you can only go into certain parts but not others. So it says graph this function, y equals negative 3x plus 1, with a domain x, some symbol, and then 0. Then identify the range. So first, our symbols, we could have this symbol or this symbol. One's less than and one's greater than. If you make an L with your fingers, here's your hand. If you use your hand, 1, 2, 3, 4, form an L with your fingers, your pointer finger and your thumb. That finger, your left hand, forms the less than symbol. So this one that looks like an L means less than. The one pointing the other direction in your right hand means greater than. The line underneath it means or equal to. So this would be less than or equal to, and this would be greater than or equal to. And this symbol is just smaller right here. This is less than, and this is greater than. So our domain, what we're plugging in for x, is going to be like an L, less than or equal to 0. So if we were starting at 0, could be equal to 0. Numbers that are less than 0, they're not positives, they're negatives. So less than 0 would be -1, -2, -3, and -4. I like to plug in 5 numbers. If you want to plug in less, that's fine. So I know my x's only have to be on the negative side eventually when I graph. I know I'm not going to graph anything on this side because the x's are less than or equal to 0. They can't be greater than 0 here. They have to be less than, only on the left side of the graph. Okay? So next, I am going to put in my equation into my table. We have -3x plus 1. So first we're going to plug in a 0. -3 times 0, and then add 1. Well, anything times 0 is 0. 0 plus 1 is 1. Then we're going to plug in a -1. -3 times -1, and then we're going to add 1. Well, a negative times a negative makes a positive. 3 times 1 is just 3, and 3 plus 1 is 4. If you want to use your calculator, you can. We would type in -3 times -1, and then plus 1. We got 4. Then we're going to plug in a -2. -3 times -2, and then plus 1. A negative times a negative makes a positive. 3 times 2 is 6. 6 plus 1 is 7. You can see our pattern 1, 4, 7. We're going up by 3. So if we go up by 3 again, that will give us 10. And up by 3 again, that will give us 13. If you don't see that, that's okay. We'll just keep plugging in numbers. -3 times -3 is a positive 9. Plus 1 is 10. And same thing here. -3 times -4 makes a positive 12. Plus 1 is 13. So let's plot our points x, y. Our x is 0, 1, -1, 4, -2, 7, -3, 10, and -4, 13. So first, x is left to right, y is up and down. So x is 0, y is up 1. Then x is -1 to the left, and then up 4, positive 4. We plotted that. Then we have -2 to the left, and up 7, 5, 6, 7. -3 to the left, up 10, which is right at the top. So that means I can't even plot this last one, and that's okay. So our points, instead of drawing a line all the way through both sides, we're starting here and we're only going to the left because we said that our x's have to be less than 0. They had to be on this side of the graph. We couldn't be on this side because they're not greater than, they're all less than 0. So then last, identify our range. Our range is our y values because our domain was our x values. Our domain is our x, range is y. So if we think about it, think back up here, x was less than or equal to 0, Let me erase this here. X was less than or equal to 0. These all went less than 0. So if we had to start at 0, here we started at 1. And are these numbers greater than or less than 1? Well, they are greater than. So the symbol meaning greater than or equal to 1. Because all these numbers are greater than 1. We don't need to list them all out. Let's try another one, same thing. Alright, here we go. Graph our function with a restricted domain. But before we can graph this, we need to solve this one for y. So get y all by itself. I'm going to have to add the 2x over to the other side. So those are gone. I have y equals 2x plus 3. So now y is all by itself, just like we had back here. This one we just didn't have to solve. So let's make our table so we can graph. Maybe move this over a little bit. So we have x and we have y, and our equation goes in the middle, 2x plus 3. So our x's, this time, L is for less than, remember, the other way is greater than. So this symbol must be greater than or equal to 0. So numbers greater than 0 would be like 1, 2, 3, 4. So we're going to plug those in for x. So 2 times a 0 first, and then add 3. Anything times 0 is 0. 0 plus 3 is 3. Then we have a 1, 2 times 1, and then add 3. 2 times 1 is just 1. I'm sorry, 2 times 1 is 2. 2 plus 3 is 5. Then plugging in a 2. 2 times 2 is 4. Plus 3 more is 7. You can see 3, 5, 7. Next would be 9, and then 11. We're going up by 2 each time. If you want to keep plugging them in, you can. We would plug in next a 3, and then a 4. So let's plot these points. First we have x, and then y. So 0, 3. I'm going to write them all out. If you can just look at the table, that's fine. I'm just looking at x, and then y. 3, 9, 4, 11. X goes left to right, y is the longer letter, goes up and down. So let's plot these points. First, left and right, x is 0, we're not going left and right, y is up 3, positive 3. Then 1, 5, x is 1 to the right, up 5. Then x is 2, y is 7, so 2 to the right, up 1, 2, 3, 4, 5, 6, 7. Notice I'm forming a nice straight line. 3 to the right, up 9. And 11 doesn't actually fit on our graph. That's okay. So notice our x's this time were greater than 0. They were on the positive side. They were greater than 0. We didn't have any on the negative side. So this time, our line is only going to the right. The ray is going to the right. That's what we call this line, where it's stopped on one side and just goes in one direction. So last, our range is our y values. So our x's started at 0 and went positive. Our y's start at 3 and are also going positive. They're greater than, not like in L for less than, greater than or equal to 3. Alright, this is our last one. Graph the function y equals 4 with a domain x is like an L less than or equal to 3. Then identify the range. So this one is already solved for y, so I'm just going to make my xy table. X, y. And x is going to be less than or equal to 3. So we're starting at 3. And numbers that are less than 3 would be like 2, 1, 0. If you want to go negatives, you can. So there's nothing really to plug in. All it says is y is 4. So really, there's nothing to plug in this middle equation. Y is always going to be 4. So our points are going to be 3, 4. 2, 4, 1, 4, 0, 4, and negative 1, 4. So let's plot those. X is 3, so 1, 2, 3 to the right, and y is up 1, 2, 3, 4. Then we have 2, 4, so 2 to the right, up 4. Then we have 1 up 4, 0 up 4, and then negative 1 up 4. So here our line is only going to the left because we're less than or equal to 3. We can't plot anything greater than 3. So our range, what we get out then, our range, aren't they all the same? So our range is just y is equal to 4, always. There we go. If you haven't finished your stained glass window project from the other day, let's finish that up and then we will work on our homework.